All right, you guys, so here's some more 2.5 like questions going on. One's actually kind of some nice diagrams, and then what we have below are some word problems. So we'll take a look at each. Hopefully you'll see some situations that we've already talked about come into play, and we can go from there. So for the first one, you'll notice that I am asking for an exact value, all right, for the x that's being shown. So that's my way of saying put the calculators down, right? They're not needed here. You can do this problem without a calculator. So let's take a look at the first one. So what we have to do is find this value of x all the way down here on the bottom. And luckily what I have is a 45, 45, and a 30 right triangle, triangle. What we have to do to get our sines, cosines, and tangents involved is we need that right triangle that I kind of let slipped out. Well, using the same trick that we just did, right, the idea is to put a line segment that's perpendicular, right, to the area, the side we're interested in, and let it come up here, right, and kind of intersect that angle that we have there. And so by doing that, what I've done is created two right triangle situations. To the left, I have a 45, 45, 90, and to the right, I have a 30, 60, 90. So what we can do, right, how about again we call this x1 and x2, right? Our x is basically the sum of x1 and x2. So our job now comes down to finding out what those values are. Well, in the first one, let me change colors here, right? So in this 45, 45, 45, we know the relationship is, right, is that this is going to be, if this is 16, right, then these sides, right, the idea is these sides would also have to be 16. So again, it was side, side, and then side square roots of 2, right? So I'm kind of abusing some things here, but if this is A, this is A, that's A square roots of 2, right, for a 45. So there's the relationship for that. So I already know this is 16 square roots of 2, so that forces that and that to both be 16. So we're solid. So we know that x1 equals 16. What about x2 on this side? Well, again, by doing all that, I've helped myself. I know that that side is 16, and lo and behold, right, the relationship for this, for a 30, 60, 90, we have a 2a and a square roots of 3. So you can already see that coming, right? So this side's 16, the side opposite of the 30, so that means this side's double that, 32. So this means that x2 is 16 times the square root of 3 using our 30, 60, 90 relationship. So now I know x1 and x2. We'll come back over here. What's my x value? It's my x1 value plus my x2 value. Of course, you can factor out that 16 and write it like that, right? I don't really care at this point, but there would be your exact value of that x, right, from this from that point to that point. So again, no calculators are necessary. We just fell back on this new trick of bisecting that. Again, the idea is we want not to bisect the angle here, but we want to create a perpendicular situation to the line I'm trying to find, and then let that come up here, create the math that comes up. So there you go. All right, so over to the next one. Again, the x is way over here, so we're going to kind of piece this together. So the first triangle, let me highlight it in red. That triangle that I have in red, since that's 45, means that's 45. So what we're basically looking at, right, is this situation here. Side are equal, and then the hypotenuse is whatever that side is, square roots of 2. So if that's 24, that forces that to be 24, which forces that to be 24 square roots of 2. Okay? And so now it gets a little challenging because let me rewrite this this piece right here, right? Let me orientate a little different. Here's where we're at. So for that little piece, here's x, right? This is 60 degrees, which forces that to be 30 degrees, and we know that this is 4 square roots of 2. All right, and so labeling this, we know that this side is always a, this side is 2a, and this side over here is a square roots of 3. So basically that means that this has to equal that. And so to solve for a, I would basically divide both sides by the square root of 3. And so we would get that a is 24 square root of 2 all over the square root of 3. Multiplying, that, we get that a is 24 square root of 6 all over 3. And so a is basically 8 square root of 6. So we now know what a is. It's 8 square root of 6. Of course, what's this side? Well, that's double whatever we just found. So 8 square roots of 6, which is 16 square roots of 6. So this x on this side, after following that around and using my relationships, is 16 square roots of 6. All right, so there's some terminology from, again, we're solving some crazy right triangle situations, trying to find a side, and since everything was embedded in some nice special right triangles, I use those special right triangles and their relationships to piece things together. All right, so much crazier situations. Again, the more you can memorize those special relationships in a right triangle, the better you're going to be at this. We're 6 minutes into this. We got some word problems to do. So why don't I pause, create a new video where we go handle those word problems.